and thank you for watching the videos. In this video we will discuss a question which is related to conicoids, but it is under the topic of reduction of general equation of second degree also, and this question has been asked in 2017, but the language was little bit different and here language is different. So we will see question in both forms and we will solve the question. Question which was asked in 2017 was, it is a definition of director sphere also, that we have to find out the equation of director sphere of the conicoid. So to find the equation of the director sphere of the conicoid, ax square plus by square plus cz square is equal to 1. And definition we can say, and that this was the question in 2017, that we have to find the locus of the point of intersection of three mutually perpendicular tangent planes to a conicoid is defined as the director sphere. So we can write in the form of question, but right now I am writing the form of definition. The locus of, in that we will say find the locus of the point of intersection three mutually perpendicular tangent planes to a conicoid is defined as director sphere. In that case we can write find the locus of this and need not to write of up to this. So then it will be the question which came in 2017. And when we are thinking of reduction of general equation of second degree, this is lecture 3, as you know. We have done 2 lectures till now on this topic. So this says the question is, show that the question in another form, show that the locus of the point of intersection of three mutually perpendicular tangent planes to the surface fxyz is equal to 1 is the sphere dx square plus y square plus z square is equal to a plus b plus c. So this form we will be solving, which we have done in last 2 lectures, and this form we are solving with the help of conicoids. So first we will see conicoid 1. In this the equation of conicoid is given this one. So we write that equation of conicoid is ax square plus by square plus cz square is equal to 1. This is equation 1. And equation of the tangent planes to 1 are this we will be taking by condition of tangency. From there we get these planes, and because there are 3, so we will write L1 M1, then L2 M2, then L3 M3, etc. So L1x plus M1y plus n1z is equal to under root L1 square upon A plus m1 square upon B plus n1 square upon C. This is equation 2. Then we have L2x plus m2y plus n2z is equal to under root, this is on whole, so this is L2 square upon A plus m2 square upon B plus n2 square upon C. This is equation 3. Third one will be L3x plus m3y plus n3z is equal to, we can replace this by 3. Equation 4. Now we can write down the condition of perpendicularity, that is, if the above 3 planes are mutually perpendicular or mutually at right angles, we get, so here you write the word mutually also. We can write down L1 square plus L2 square plus L3 square is equal to 1, m1 square plus m2 square plus m3 square is equal to 1, n1 square plus n2 square plus n3 square is equal to 1, and similarly L1 m1 plus L2 m2 plus L3 m3 is equal to 0, and L1 n1 plus L2 n2 plus L3 n3 is equal to 0, and one more will be m1 n1 plus m2 n2 plus m3 n3 will be 0. So these are the conditions. So we denote all these as 5. Now we know that to find the equation of director sphere of equation 1, we have to find out the director sphere equation of this equation. So for that we have to find the locus of the point of intersection of the 3 tangent planes, that is, we have to eliminate L1 m1 n1, L2 m2 n2 and L3 m3 n3 from 2, 3 and 4. From all these equations we have to eliminate all these L1 m1 n1, L2 m2 n2, L3 m3 n3. So for that we will be squaring and adding. So squaring and adding equations 2, 3 and 4. What we get, we take left hand side L1x plus m1y plus n1z whole square these we got on left hand side is equal to, we club the terms and take, after squaring we take common, so 1 upon A L1 square plus L2 square plus L3 square plus 1 upon B m1 square plus m2 square plus m3 square plus 1 upon C n1 square plus n2 square plus n3 square, or we can write down we take these terms, x term on left hand side, so this is x square and L1 square, L2 square, L3 square, so we write sigma L1 square, that is L1 square plus L2 square plus L3 square. Similarly for y square with this term, so y square sigma m1 square, this also m1 square plus m2 square plus m3 square plus z square sigma from this term n1 square, so sigma n1 square plus n2 square plus n3 square. Now we take xy twice, so because this is a square, so twice of xy, this will have sigma L1 m1, this is L1 m1 plus L2 m2, because from here it will come, and plus L3 m3 plus 2yz sigma yz will have m1 n1 m1 n1, and this will be 3 terms plus twice zx will have x and this, so L1 n1 L sigma L1 n1 is equal to, right hand side this term will be 1, because we have seen all these are 1, so this will be 1 upon a plus 1 upon b plus 1 upon c, because sigma L1 square is equal to 1, etc. we can say. So we can write down this also 1, this also 1, and this also 1, and they are 0, these terms are 0. From by using equation 5 we can write x square plus y square, because this is 1, so this is 1, plus z square is equal to, all these 3 are 0, so only right hand side is there, 1 upon a plus 1 upon b plus 1 upon c. So this is the equation. And if we take the equation of ellipsoid, then we have x square upon a square, if this type of equation is there, y square upon b square plus z square upon c square is equal to 1, then this equation will be x square plus y square plus z square is equal to a square plus b square plus c square. So we got, this is the equation of director sphere for the conicoid, ax square plus by square plus cz square is equal to 1, and this is the equation of the director sphere of the ellipsoid, x square upon a square plus y square upon b square plus z square upon c square is equal to 1. Now we will come to next part where we are using reduction of equation. So as I had already written the question, that we have to show the locus of the point of intersection of 3 mutually perpendicular tangent planes to the surface fxyz is equal to 1 is the sphere D bracket x square plus y square plus z square is equal to capital A plus B plus C. If we refer our last lecture, the lecture number 2, in that we have written that the plane is given Lx plus My plus Nz is equal to 1. This plane was given and it is touching the surface fxyz is equal to, this plane touches the surface, this is ax square which was almost equal to plus cz square plus 2fyz plus 2gzx plus 2hxy is equal to 1. So this was the surface which we can denote by equation 1. Right. Now this we have already done. Then we said that the plane Lx plus My plus Nz is equal to 1 touches the surface this when if this condition is fulfilled. AL square plus BM square plus CN square plus 2FMN plus 2GNL plus 2HLM is equal to P square D. This is equation 2. So we had proved this condition in the example in previous lecture. So we take it from there, and in the examination if it comes, you can show this. If it is not shown, you have to show that this condition we have achieved. In other words, we can say that Lx plus My plus Nz is equal to P is the equation of the tangent plane to equation 1, that is the equation of surface, where P is given by this condition which is given by equation 2. So this is the point we have made already. Now let L1x plus M1y plus N1z is equal to P1. So if we take similarly, we can write it in generalized form, that is LRx plus MRy plus NRz is equal to PR. So we take this where R takes values 1, 2, 3, because 3 mutually perpendicular tangent planes are there, so we will write this. Hence P, which we have obtained from equation 2, that can be written in terms of PR. So PR is given by ALR square plus BMR square plus CNR square plus 2FMR NR plus 2GNR plus 2HLR MR is equal to PR square D. This is equation 4. We put R is equal to 1, 2, 3 in equation 3. Equation 3 was LRx plus MRy plus NRz is equal to PR, and R was 1, 2, 3. So we put that and square them and add them. So from here we will get x square, because we are squaring and adding, and L1 square plus L2 square plus L3 square, which we can write in the form of sigma also, x square sigma L1 square. Similarly for y square, m1 square plus m2 square plus m3 square plus z square n1 square plus n2 square plus n3 square is equal to p1 square plus p2 square plus p3 square, and we know these are 1, so we can write down x square plus y square plus z square is equal to, now p1 square from equation 2 we can have, which will be 1 upon d, because from second we divide left hand side by d and get the equation. So A, now we write in sigma form, sigma L1 square plus B sigma m1 square plus C sigma n1 square plus 2f sigma m1 n1 plus 2g sigma n1 L1 plus 2h sigma L1 m1 is equal to 0, and we know these are the cofactors of we know A, B, C are the cofactors of the corresponding small letters in the determinant. And determinant we had seen that it was like A, B, A, H, G, A, B, C, we A, B, C, A, H, G, and here it was LMN. So F, G, H we take in this order, F, G, H. This is LMN, A, B, C in this, to remember this. And from here this will be F, G, H in this order. This is clockwise, this is anti-clockwise. ABC is this, LMN in this order. And last was LMN P square is equal to 0. So this was the condition of tangency. In the question 2, okay, and A, B, C, etc. are the cofactors of the corresponding small letters in the determinant, not in this determinant. This is condition of tendency, but only this determinant, which is A, H, G, F, and F, G, H. So A, H, G, F, A, B, C, and this is equal to D, you can say. So in this, these are the cofactors of the corresponding small letters in this determinant. This is condition of tendency. So please just remember what we have taken here. A, B, C, F, G, H. These are the cofactors of the corresponding small letters. These are small letters in this determinant D. Okay. Now we have to write down the value, final value, because these will be 0. Sigma M1 N1, these will be 0, this will be 0, and these are 1. Sigma N1 square, sigma M1 square, sigma L1. So we can write down x square plus y square plus z square is equal to 1 upon d. D we bring here is equal to A plus B plus C, because 1 upon d we have brought here. So cross multiplication, and this is what we had to prove, right? And this is the equation of the required locus, and this clearly represents a sphere concentric with the given conicoid and is called the director sphere. And then in next lecture we will be doing next article.